Hello, this video is for Math 112. This is for section 3.3, solving trigonometric equations. So the first thing I want to talk about for this section is this diagram that we first talked about in chapter 2. And this determines which of the trigonometric functions are positive in which quadrants. Okay? In the first quadrant, they're all positive. In the second quadrant, the sine and the cosecant are positive, and the rest are negative. In the third quadrant, the tangent and its reciprocal, the cotangent, are both positive, and all the rest are negative. And in the fourth quadrant, the cosine and its reciprocal, the secant, are positive, and all the other ones are negative. Okay? All right, so I often skip over the examples in the body of the text, but I think for this section it'll be really helpful to talk about a couple of these, just to get us started before we look at the problems. So the first example is very simple, sine x equals 1/2. Okay? So the process here is to undo the sine, the application of the sine to the x. It's sort of like if you're, if you've got something that says x squared equals 7, to undo the squaring, you take a square root and you get x is square root 7, and you can approximate that if you want to. So to undo the application of the sine function on the variable x, we want to take an inverse sine on both sides. The inverse sine is just a process that says the angle whose sine is 1/2. That's what it does, is it undoes the sine function. So the angle whose, let's see here, the angle whose sine is the sine of x is x. I mean, it's kind of a convoluted way to describe it, but in any event, that's going to undo the sine function, just give us the x. On this side, we want to calculate the inverse sine. In the sciences, a lot of times, they call this the arc sine to avoid using that -1 to represent an inverse. So if you run into that at some point, arc sine and inverse sine are the same thing. All right, so what do we do here? Well, if you know that the sine of 30 degrees is 1/2, then you can solve that on your own. Otherwise, we would look to the calculator. And when these things get, to more difficult values, then the calculator will become more important. So, let's see here. All right, so there's the calculator. Right above where it says sine, you can see there's the sine inverse. Okay, so you want to hit second sine, and there's the sine inverse. And then we'll type in the 0.5. And there we go, 30 degrees. Now, again, make sure for these problems that your calculator is set in degrees rather than radians. Okay, so 30 degrees is the answer. Let's see, let's get some focus back on there. All right. So, x is 30 degrees. Well, that's good because we know that the sine function is positive in the first quadrant, and so that x being 30 degrees is going to be one solution to this problem, but there are other quadrants where the sine function is positive, like in the second quadrant. So if we put a reference angle of 30 degrees into the second quadrant, then the angle that corresponds to that is going to be 180 minus that 30, which is 150 degrees. So that's also a solution. Okay? Now, a lot of times if you make a graph for a trigonometric function, so this is just the standard sine graph, and we want to know where is it equal to 1/2, So we're going to see an infinite number of solutions along this graph, because as long as the sine graph keeps going and this y equals a half keeps going, okay, then you're going to have intersections here. Now in the graph, these are going to show up as radians. Okay, you can convert them to degrees, but in the graph itself, they're going to be shown as radians. But this would correspond to pi over 6, which is 30 degrees, and this one over here is 5 pi over 6, which is 150 degrees. Okay, so we're going to limit our answers to be between 0 and 360 degrees, or 2 pi radians. Okay, if we need answers outside of that range, then we can consider other possibilities. But for our purposes in this chapter, we're just going to focus on solutions between 0 and 360. Okay, so there's the first example, and when we get to the problems on page 120, we'll see some more of these as well. And so hopefully we'll get enough practice working with them so that we get a sense of how to approach them. All right, let's see here. Now, example 2, we've got tangent x equals 4. So again, this is pretty straightforward. All we've got to do is take the inverse tangent on both sides. This side will just be x then. Over here, we've got inverse tangent of 4. And let's see what we get. It's a similar process as we did for inverse sine, so you just go second tangent and then type the 4 in there. And that would be, let's see, say we're around, it doesn't. I've rounded to the hundredths place in the textbook, so I'll go ahead and carry that on. Let's see, 75.96 degrees. Very close to 76 degrees. The tangent is positive here, so it makes sense that, yeah, in the first quadrant, this angle of 75.96 degrees is going to have a tangent of 4. Okay? But this tangent is a positive 4, and down here in the third quadrant, we're going to have another angle that has a reference angle of 75.96 degrees. So to find that angle, there's the whole angle. So that's 180 plus that extra 75. Looks like it should be 255, I believe. Let's see here if I add 180 to that. 255.96. Okay, and so we would list that one as well. Now we know there's no solutions for this in the second and fourth quadrant, because in those two quadrants the tangent is negative. Okay, the tangent's only positive here and here. All right, so there's the second example. Let's see here. Well, let's take a look at one of the reciprocal functions. This is example number 4 on page 125. Oh, I guess the exercises for this section are on page 127. I said 120 a few minutes ago. All right. So on page 125, we've got example 4 here. Secant x equals 12. Okay. Well, our calculator doesn't have an inverse secant function. So what we can do is we can rewrite this as 1 over the cosine is equal to 12 over 1. Now take a reciprocal on either side. So that says that the cosine should be equal to 1/12. Okay? All right. Now it's the same as those other problems. We're going to take an inverse cosine on both sides. That means this side will just be x. Over here we'll get inverse cosine of 1/12. Let's see what we get there. inverse cosine 1 over 12, 85.22 degrees. 85.22 degrees. Let's see here. So, now, where else between 0 and 360 would we get a cosine of 1/12? Well, let's erase all of that. It's getting a little messy. Okay, so the cosine was a positive 1/12, and that means we're going to get this angle 85.22 degrees in the first quadrant, but the cosine is also positive in the fourth quadrant. So we put a reference angle of 85.22 into the fourth quadrant, and then we can calculate what is the angle that has that reference angle. So that's going to be 360 all the way around, take away the 85.22. And let's see what we get here. 360 minus 85.22, 274.78. 274.78 degrees. And that's going to do it, because this is always, we're looking for x's just between 0 and 360. Okay? We can talk about how to represent the infinite answers that exist. But for our purposes, just as an introduction to this topic, we're just going to limit our consideration to between 0 and 360 degrees. Okay, so let's go ahead, now that we've talked about those basic ideas, let's go ahead and look at the even problems on page 127 here. Let's see. All right, let's see here. So, this is page 127. I'll put this back up, but I'll draw one over on the side for each problem that we're doing here. Okay. So, problem 2. We've got sine x plus 0.432 equals 0. So move this to the other side. Sine x is negative 0.432. So now let's take the inverse sine. X will be the inverse sine of negative 0.432. Let's see what that is. Inverse sine negative 0.432. And so the calculator returns an answer of negative 25, let's see, does it say around to the nearest tenth of a degree, 0.6 degrees. So I think I did talk about this. There is an example in here. Yeah, I skipped example 3 when I was going over those examples. So if you want to see another example that has this same idea in it, you can look at example 3. But what's happening here is that this calculator has been programmed to really just return answers between positive 90 and negative 90 degrees, whereas I'm asking for answers between 0 and 360 degrees. So that's a little bit different. But we can still use this information. So this angle, negative 25.6, appears in the fourth quadrant, and it does have a reference angle of 25.6 degrees. So we can use that to figure out the fourth quadrant angle that has a sine equal to negative 0.432, right? That's this angle right here. Now, with this reference angle of 25.6, you can take the 360 and subtract that away. And what is that going to be, like 334 or something? Let's see. Yeah, 334.4 degrees. Okay, so that's going to be one of our answers. 334.4 degrees. So we can use this 25.6 to find a fourth quadrant angle. Now, let's see. The sign is negative here, so the sign is positive in the first and second quadrants, but it's going to be negative in the third and fourth. So we've got our fourth quadrant angle. Let's put a reference angle of 25.6 in the third quadrant. And so then we would do 180 plus that 25.6. I believe that would be 205.6. 205.6. And those are our answers. And there we go. Okay? Notice we left out that negative angle because it's not between 0 and 360. Alrighty? Okay, let's keep going here. Problem 4. Sine x minus 4 equals 0. Add the 4 to the other side. Sine x equals 4. Now, if you've read through the chapter section already, 3.3, I believe I do talk about this at some point. Or if you remember what it looked like when we were graphing a sine function, then you might have some advanced idea of what's going to be happening here. Okay? So remember, let's look at the graph of the sine function again, right? So it's going to be doing that in that direction. It's going to be doing this in this direction. Now we're back to just the standard sine function, the simplest, really, of the trigonometric graphs, right? It's got a maximum value of 1, a minimum value. Wait, what did I just say? A maximum value of 1. How can it be 4? Well, like a lot of problems in mathematics, you actually can solve this using complex numbers, okay? But you can't solve it using real numbers. So, no real solution for this right here. And I'll show you what happens on the calculator when we try to take the inverse sine of positive 4. It is not very happy about it. Okay, so let's see. There's the calculator. And so then if we want to do inverse sine of 4, right? And what is that going to look like? Yep, error, domain. Okay, so it's not, the calculator won't find inverse sines or cosines if your numbers are greater than 1 or less than -1. And so you can say no real solution. I think it's really interesting. You can generate complex valued angles as solutions for this. I'm not really sure what a complex valued angle is supposed to represent. I've thought about it for a while, and I haven't really arrived at any good answers. Okay, so that's problem 4. Let's keep going here. Now remember, a tangent can be any value, from negative infinity to positive infinity, including 0 and everything in between. So don't worry about that with the tangent. It's the sines and cosines that are restricted to being between -1 and +1. Problem 6, we've got 4 cosecant x plus 9 equals 0. So let's get the cosecant by itself. And divide by 4. So this is going to be -2. Well, I'll leave it as 9 over 4 because we're going to take a reciprocal here in just a minute. 9 over 4. Okay? So 1 over the cosecant is 1 over the sine. And so that means that sine x will be -4 over 9. And so then x is going to be the inverse sine, -4 over 9. And again, if you're in the habit of using decimals and then rounding them off, don't just call this 0.4. There's nothing wrong if we did inverse sine and you put, I don't know, 6 or 7 or 8 of those 4s in there, then that'll take care of any accuracy problems. But if you're in the habit of just taking the first digit that you see, your answer is going to be way off. Okay? So do be careful with your accuracy when you're doing these problems. So let's see here. Inverse sine -4/9. And again, the calculator is very picky about this negative sign. If you type in the subtraction sign, it'll give you an error. It's the negative sign right below the 3 that we need to use here. -4/9. And so again, because this answer is negative, we're going to end up in the fourth quadrant again. -26.4 degrees. Okay, so what that says is we're going to be in the fourth quadrant with a reference angle of 26.4 degrees, and the angle that we're interested in, which is this one right here, is going to be 360 minus 26.4, which is going to be 333.6. So x is going to be 333.6 degrees. And then also over in the second quadrant, if we put a reference angle of 26.4 there, add the 180, right? Then the angle that we're looking for in this situation, let's see, is going to be that angle right there. So that's going to be 180 plus that 26.4, so that should be 206.4. Okay. That's problem 6, right? So we've got all our answers now between 0 and 360. This was helpful to us in finding these answers, but this is not one of the answers because it's not between 0 and 360. All right, let's keep going here. Well, I said I wasn't going to use that diagram, but I did anyway. Okay. Problem 8. Cosine x minus 5 equals cosine x minus 3. All right. So let's collect our cosines together and move the constants to the other side. So those will cancel out. And then I'll subtract 1 cosine x on both sides. So this will be positive 2. Over here, we'll get 3 cosine x, and then divide on both sides by 3. So cosine x is then going to be 2/3. Okay, so now we just need to take the inverse cosine of 2/3. 48.2 degrees. Okay. Now here the cosine is positive, and we know that the cosine is positive in the first and fourth quadrant. So there's our first quadrant angle. Now we need a fourth quadrant angle with a reference angle of 48.2 degrees. Excuse me. That's this angle right here. And so we do 360 minus 48. Let's see here. 311.8. Yeah. And so there's our two angles, one in the first quadrant, one in the second quadrant. Good. All right. So that's the first part of these problems in section 3.3. The next set of problems involves quadratic equations. So let's take a look at those. Problem 10. So, 4 cosine squared x minus cosine x equals 0. Okay, well, we should all have the quadratic equation programmed into our calculator. If we haven't done that yet, let me know, and I will try to help you out with that. In any event, so you can solve this using the quadratic equation: a equals 4, b is negative 1, c is 0. Let's see what that comes out to be. And then our cosine x will be equal to 0.25 or 0. Okay? You can do this one by factoring as well, right? If you factor out a cosine from both these terms, then you'll get 4 cosine x minus 1, and this one will say cosine x equals 0, and this one will say cosine x equals 1/4, and that's what we've got up here. Okay, so we've got two equations to solve now. Cosine x is 0.25, or cosine x is equal to 0. Okay, let's do this one first. X is going to be the inverse cosine of 0.25. So, inverse cosine 0.25, 75.5 degrees. Okay, that's a positive answer. All right, so the cosine is positive in the first and fourth quadrant. So here's 75.5 degrees. Here's the reference angle of 75.5. And to get that angle, we need to do 360 minus 75.5. And that'll give us 284.5 degrees. So there's two solutions. Over here, x is the inverse cosine of 0. Inverse cosine of 0. And that's going to give us 90 degrees. Now, here's something that the calculator won't do for you. All right, so let's talk about this a little bit. Let's see. You remember in chapter 2, we talked about the quadrantal angles, right? So at 0 degrees, this point right here, so this is the unit circle, right? So the cosine of 0 and the sine of 0 should match up with this point, which has the coordinates 1, 0. This point up here is the point 0, 1. This is 90 degrees, and so this matches up with the cosine of 90 and the sine of 90. And so there's the cosine of 90 being 0, and that's what we got from the calculator here. Okay, back over here, this is 180 degrees. The coordinates are negative 1, 0, and so this is the cosine of 180 and the sine of 180. So what the calculator is not telling us is this point down here is the point 0, negative 1, and that's at 270 degrees, and so the cosine of 270 is 0, and the sine of 270 is negative 1. Okay? So this unit circle diagram is very helpful for generating the sines and cosines of what are called the quadrantal angles, which are all multiples of 90. Okay? All right, so with that, all of that is to say that we need to include 270 degrees in our answer. So we've got 4 answers: 90, 270, 75.5, and 284.5 degrees. Okay? All right, let's keep going with these. Okay, let's see here. Problem 12. 2 cotangent squared x minus 7 cotangent x plus 3 equals 0. Okay. So, this one, let's see. I guess this one is also factorable. I'm just going to use the quadratic formula for this. So, let's see what we get here. A is 2, B is -7, C is 3. And so what we get here is, and remember, we're solving for cotangent of x. We're not solving for x here. We're solving for the cotangent. And what we get is cotangent is equal to 3, or cotangent is equal to 1/2. And again, the calculator does not have an inverse cotangent button, and so we need to say tangent of x is 1/3, and over here, tangent of x is equal to 2. Remember, the tangent can take on any value. If you're ever not sure, try doing an inverse function on your calculator, and if it gives you an answer, that's fine. If you do like an inverse sine or cosine on 2, you'll get an error message. Okay, so let's look at inverse tangent of 1/3. Inverse tangent 1/3, 18.4 degrees. Okay, the tangent is also positive down in the third quadrant. And there's our reference angle of 18.4. If we add that to 180, then that should be 298.4. Okay. Over here, tangent equal to 2, so inverse tangent of 2, 63.4 degrees. And again, this is also positive, and so we want a third quadrant angle with a reference angle of 63.4, and if we add that to 180, 243.4 degrees. So again, we've got 4 answers for this quadratic equation here. All right. Let's see, I think we've got 2 more problems to look at, 14 and 16. Problem 14, 2 sine squared x plus 5 sine x plus 3 equals 0. Okay, let's see. I don't think this one is factorable, but it doesn't matter. I'm going to use the quadratic anyway. Or, oh yeah, I guess it is, isn't it? Yeah, it is. Okay. So what do we get here? We get sine x could be -1, or sine x could be -1.5. All right, well, the sine x is never positive or -1.5 unless x is a complex valued angle, okay? So this one, no real solution. Right? There are complex valued solutions. Over here, sine x as being -1. Let's do inverse sine -1. Now notice that the calculator again returns a negative valued angle. So this can at least point you in the right direction. The angle -90 is coterminal with the angle positive 270. Okay? And 270 is between 0 and 360. So that's the answer that we want. So this equation really just has one answer, 270 degrees. That's the only place between 0 and 360 where the sine is equal to -1. Okay? And you can also get that from that quadrantal angle diagram that I drew before. let's see. Yeah, so when you get something, a sine or cosine equal to 0, you'll typically have two quadrantal angles that match that. But if it's 1 or -1, you'll typically just have one angle to match up with that. All right, let's look at one more problem here. Problem 16. All right, 3 sine squared x minus sine x minus 1 equals 0. All right, so use the quadratic here, 3 minus 1 minus 1. And what we get is sine of x is approximately, let's see here, 0.76759. It probably wouldn't be the end of the world if I called that 7676. But we definitely want to go 4 digits if we're going to approximate these. Let's see, the other one is sine x is approximately negative 0.43426. 43426. Okay. Now, the other thing that you can do here, I'll show you this on the calculator, is that I've got these values stored in the calculator as R and S. Okay. Okay, so there's the quadratic program solving that quadratic equation. That's where I'm getting those values from. I'll show you what that program looks like here. So there it is. You just enter A, B, and C, and then it calculates the roots and stores them and displays them as R and S. And so I can go inverse sine of 0.76759 and get a solution there. I can also do inverse sine of R because that's the first answer it returned. And you can see how close they are. Okay, you can see there's a little bit of difference, but if we're rounding to the nearest tenth of a degree, then there's no difference. Okay, and I'll do the same thing for the other one as well. Sine of negative 0.43426 versus inverse sine of S, because that's what that full value is stored as. And again, they match up to the thousandths place, and then there's discrepancy. So in any event, as long as you do a good job of rounding the answers, you don't have to worry about too many decimal places after that. But yeah, it's good to get 4 or 5 decimal places of accuracy for these values. Okay, so the first one we got there was 50.1 degrees. And then let's see, the sine, so this is a positive value for the sine, so that'll put us in the first and the second quadrants. And here we've got a reference angle of 50.1. So if we do 180, right, the whole thing is 180, subtract that 50.1, that should give us 129.9. And then this one where the sine is negative, this is one of the ones where it gave us a negative angle, negative 25.7 degrees. Okay, so if we look at a reference angle of 25.7 degrees in the fourth quadrant, then let's see, 360 minus 25.7, so that's going to be, what is that going to be, 334.3, right? 10, 10, 6, yeah, that makes 360 degrees. And then also in the third quadrant, the sine function will be negative, and so this angle right here is going to be the 180 plus the 25.7, or 205.7 degrees. So there's the 4 angles that satisfy this equation and lie between 0 and 360 degrees. All right, so that's it for section 3.3. We've got one more section in chapter 3, and that'll be kind of a combination of what we looked at here together with some ideas about identities, but we'll save that for next time. As always, if you have any questions about these problems, please let me know. Thanks.